Dear Doctor, my name is Richard This Group 1, my colleague Mansaka Emerson. Our title is Photo Voicing Accelerated Education Content Generation using Large Vision Models. Photo voicing basically is concerned with creating visual content, that is able to illustrate a given topic. So, okay, narrative digital visual content that is able to illustrate a specific topic, and accelerated educational content generation means creating educative content at a high speed. The artificial models basically these are the artificial models are basically models that are able to study images and also generate images. The keywords photo voicing, large vision models, visual storytelling. This is maybe can be in the form of images in a story narrative. Then educational content generation. This is concerned with creating the creative content. Then text to image synthesis is creating images from text. Then narrative planning materials and others. These are the contents of my presentation. At the back of our basically Uganda refugee education crisis. This in Uganda is faced by education crisis, the refugees in the refugee areas. And this is due to the limited competence-based curriculum aligned resources and shortage of teachers, which leads to a low literacy rates. So the photo voicing AI solution will be able to generate narrative visual stories basically for these students in the low resource environments, the refugee students in the low resource environments, and culture relevant accelerated learning content. And basically, this is going to be SDG aligned offline deployment and served in refugee settlements. So it is going to be an AI-powered photo voicing platform that transfers curriculum topics and generates a narrated visual story for refugee learners culturally, and it will be basically culturally context. Basically, since refugees come from different cultures, so it is going to be multilingual, producing in the number of languages, and we will also aid in bridging the literacy gaps in Uganda, basically in refugee settlements. So, the literature review, among the papers we reviewed for the model, one is visual instruction learning, that is Lava 7B. Lava 7B, this is large language and vision assistant. 7B means 7 billion parameters, and this will enable image-guided instruction tuning and multimodal reasoning. The other is Harry, which is pathways, language, and image model. This basically will enable large-scale vision language. This is a large-scale vision language model for multilingual tasks and complex multimodal reasoning. And the other is UniControl-Net. UniControl-Net will enable controlled image generation with spatial guidance and inconsistency. This aids diffusion models or all the generative models such as the diffusion in controlling poses or the way the image should look. We have this segment anything model. Basically, this enables accurate image segmentation grounding for culturally aligned scene layouts. Then the clip contrastive language and image retraining. This enables image text alignment validation. We have the quantitative lang adapter, which is aids in memory efficiency, fine-tuning. The problem statement remains this problem. Uganda's refugee settlements lack engaging culturally relevant competence-based curriculum aligned learning materials. Basically, they are faced with overcrowded classrooms and text-heavy sources such as the large textbooks, which often traumatize learners since a learner can take time grasping a concept from a textbook than in case an image, a visual image that is relevant to a specific topic or visual images, form of a story relevant to a specific topic. These might be easy to understand. Basically, the computation problem. The core computation challenge is generating coherent, culturally accurate visual narratives for educational rooms, and this requires using multimodal understanding, controlled image synthesis, preserving character consistency, then multilingual audio-visual synchronization, and optimizing for offline deployment. So, research questions. Firstly, how can the AI generated photography create effective culturally relevant educational content for future learners? Under the following objectives, one we shall design, and then we are to design. One of the objectives is to design and implement an offline first photography content generation from. This means we aim at creating a model that is able to work offline on low resource devices such as the mobile devices like tablets, phones, among others. Develop a complete content-based curriculum aligned learning models using large vision models based on image generation. Also to tackle generative storyboarding for automated visual sequences, then to optimize rendering and deployment for local offline environments. So the contributions are this scenic shows an image of how the model that this was an image of what we have so far created or we have developed and developed. Then we do of what we've developed, where we will enter different specific topic, and the model will be able to create. Now you see this the parts of an insect. So the model is able to just create an insect. So far that is what we have. And also there is an audio recording describing the structure of the insect, basically. We will use descriptive text. So this is our methodology. Basically, under phase one is involved with instructional decomposition, where a teacher will input a specific topic, and this topic, models such as Lava, that is a large language and the vision assistant, it will be able to create, to break down the topic into three. Okay, it will decompose it into 3 steps, basically. Let's say how to grow maize. It will be step 1, maybe tilling land, step 2, preparing the seeds, step 3, sowing. So these models such as Lava, since it is a vision model, it will be able to create images. It will be able to interpret these text and create images such as image 1, image 2, image 3. So which will later be compiled into an asset bank. Then the phase 2 involves on-device learning, where a mobile device, the mobile device-based application, unit application used by students. Dataset description, basically, as you see, our dataset has 165 comprehensive biology entries for Ugandan Senior 1 to Senior 4 curriculum. And basically, our dataset is locally made. We made it manually by ourselves. So, but its evaluation, it's 100% complete, and 90% and 90% removed. As you see the EDA results, basically now data set the frequency and the exposure data analysis. Here we have an exposure data analysis of our data set. Here, this visualization shows the frequent keywords used, function, oxygen, photosynthesis, among others. So this is another visualization of our data set, and this shows the different topics in different levels, senior 1 to senior 4. As you see here, they are listed: introduction to biology, insects, ecology, among others. So output results. Based on the comprehensive experiment results, the proposed photoprocessing system demonstrates significant improvement across all evaluation metrics, where the interpretation of the unique control net, basically, as we learned earlier, this is for aids generative models such as stable diffusion in how the image should, or in how shaping of the image, how it should be, poses, edge maps, among others. So this unique control net will be fine-tuned on stable diffusion, and it achieved 98. I was fine-tuned in stable diffusion and achieved 91.5% accuracy. Basically, for culture relevant applications, substantially outperformed baseline models with 35.2%, and it was fine-tuned only, and it approaches 68.9%. The quantitative low-rank adapter adapted Lava, a Lava model which maintained 98.7% of full fine-tuning performance, which reduced memory requirements by 71%, and the key-based validation system successfully filtered semantically misaligned content with 92.3% precision, as you see in the tables. Explainable AI results and discussions. As you see the tables, the quantitative and human evaluation results reveal a clear narrative of the shelf baseline stable diffusion model performed poorly on culture metrics. Culture clip on 0.15 for accuracy, which is 35.2%. So the integration of the control net in our proposed model provided the explainable mechanism to precise control by conditioning the diffusion process from explicit spatial inputs like edge maps and semantic segmentation masks, and we directly injected the structural blueprint of a scene, and this is why the model achieved 94% accuracy in replicating traditional tools. So this is a continuation of explainable AI. So from the tables, explainable system integration, the two-phase architecture, the overall cloud on device architecture. Architecture is a master stroke of the explainable system design for constrained environments, and it makes the system's capabilities and limitations satisfied. So extend reference interpretation of the system architecture. The division of labor is clear, justified. So phase one, this is where the computationally intensive non-time tasks result. Running large diffusion models such as stable and control net, complex large language models like Lava, and high quality text-to-speech generator. So the explainable reason for placing this in the cloud is that it requires significant GPU resources and can be done asynchronously by the teacher during the same preparation. So model selection, the deployment, the selection model at Lava, the large language and vision assistant, which has 7 billion parameters for instruction decomposition, then unique control net for culturally consistent image generation, and mobile VLM for on-device P&A, and complete text-to-speech for multiple narration. So this is our architecture. As I spoke earlier, this is a two-phase architecture where we have the cloud-based authoring and the on-device learning. Under cloud-based authoring, a teacher's prompt is decomposed into three steps basically, or a number of steps basically. Then those steps under models such as Lava, large language and vision assistant, images are created for each of the steps, and these are converted into a narrative visual story. So this is a demonstration of the model and the working system.
They're made of tiny building blocks called cells. They are the basic unit of life.
So that is the short video shows what is so far available for our model.
Three parts. The head,
So the system basically generates culture relevant education content for refugee learners and demonstrating improved engagement and comprehension. However, the limitations are dependent on initial curriculum quality and limited device compatibility and the ongoing needs for cultural validation. Yeah. The limitations and solutions, device dependency, which will be solved by partnering with hardware donors for bundle deployment. We have content scope. The scope is basically on biology, which will later be expanded. Then resilience on power, reliance on power. We shall integrate solar. Basically, the solution is to integrate solar charging stations. Then teacher training is also a limitation, which is to develop a simplified train the trainer programs.
Which distribution?
So, future recommendations, future works and recommendations. The immediate priority is expanding content coverage beyond biology to include other subjects like literacy, among others, and we recommend developing an adaptive learning algorithm that personalizes content based on individual student progress. So these are the acknowledgements from where the research, the papers we used to come up with that research. Thank you.